So this is the sort of lab exercise 1 guidance lecture. So hopefully this is helpful to you as you approach the lab exercise this week. The first thing, so I'm just going to walk through this. This is all these are online. It has the objectives section, the introduction section. We'll go through a couple different aspects of what you're going to be doing. Then there's going to be this guidance section, which is kind of like a lecture, so I'll kind of walk through that relatively rapidly, though, because I want you guys to self-explore somewhat and not just rely on me teaching you how to do everything to do with this, especially with regard to C programming, because this is far from a C programming class. So we'll get started, though, and see how this goes. So the objectives of this lab are to give you some experience with C programming for the MyRio, the beginning of a device driver for the keypad and LCD screen used in the lab, and online debugging techniques. So our tools from last week that we kind of got introduced to are going to be really used to a pretty significant extent now, sort of real problem this time. So in exercises 1 through 3, we'll write several functions that will allow a user to interact with the program through the keypad and LCD screen. Below is an outline of the functional dependencies and corresponding lab exercises. So this structure should really be our map for the next few weeks. And what I've done here is I've outlined our functions, sort of which functions depend on other functions, the nesting of the functions. And we're going to be writing our own version of all these functions, although they do already exist in the ME477 library. So all these functions are already in the library, in the header file that we load in, but not the source for them. So just compiled versions. So we can pull them in, we can use them, but we don't know how they were written, keeping us honest. So we're going to develop our own versions of these that function the same. They might not be written exactly the same, they're just going to function the same. So in Lab 1, we're specifically going to be writing this top-level function, DoubleIn, and one of the second-level functions, Printf LCD. And we'll be using a couple of the other functions as well. So I'm going to walk through what these do. So at the highest level, DoubleIn prompts on the LCD screen. So it prompts the user for input on the LCD screen, and it returns a keypad entered double. So the user is prompted for a double, a floating point number, to be entered, and enters it on the keypad, and that number gets returned from the function DoubleIn, or by the function DoubleIn. So that's at a high level what DoubleIn is going to do for us. It's going to do all that. It's going to get the whole string of characters from the keypad, and it's going to convert them into doubles, or for each time it would be a double, and then return that as the value. When you call DoubleIn, you get back a double. Now, FgetKeypad is the next function down in this nesting. We'll do that in Lab 2. We'll write it in Lab 2, but we're going to use it in Lab 1. It gets a string from the keypad. So it gets an entire string, which is going to be a list of characters. Okay. At a lower level than that, inside of FgetKeypad, GetKeypad, which is also going to be written in Lab 2, gets a character from the keypad. So that's a function that just gets one character at a time. And then finally at the lowest level, down at we'll do it in Lab 3, we'll get a key from the keypad. So a key is going to then be corresponding to a character, which is then going to correspond to a string, which is then going to correspond to a double, the highest level up here. And then we want to also print that to the LCD screen. So lab 1 prints this entire, Printf LCD, which we'll write in lab 1, prints the entire string to the LCD. At a lower level than that, and this week we'll use putChar, but we won't actually write it ourselves this week. Next week, or 2 weeks from now, we'll be writing that. So putChar LCD prints a single character to the LCD. So that's the sort of lower level functionality. So it's important to note that these functions are already in that library. So when we write our own version of a function, it supersedes the library version. So as long as we've placed it in our main file, which is what I encourage you to do for the purposes of this class, in a lot of situations you'll want to have separate files for your different functions so that they can be accessed from outside of that file. However, for the purposes of this course, it's kind of nice to be able to use to have everything in one file so that we can all just share one. We can look at one file and see all of your functions in it. It's okay if you split them up as long as you make sure you submit everything when you do submit your codes to me so that I can actually run it. So good. And so those lower level functions, when we write our own Printf LCD, the Printf LCD that's in the library will be superseded, and we won't need to use it as long as ours is working. And not only will we not need to use it, but the priority of our locally written function is higher than that of one that we bring in from the library. So that's something important to note. So in this lab exercise, in addition to the main program, you will write DoubleIn and Printf LCD. In order to use DoubleIn and Printf LCD, we need to write a main, right? A main is the only, well, as we'll talk about, every C program needs to start with a main function. At this point, you're expected to have only an elementary knowledge of C, but you should become familiar with the procedures such as debugging that you'll need in the future. And really, this is a sort of, the learning curve is, I would say, difficult at this point because you're still getting some of the sort of elementary concepts of C down, and we'll talk about some of those at the end today. But I'll walk us through kind of what what we're doing in this lab first, and then I'll walk us through some C stuff. I'll probably split this up into 2 parts so that it's not sort of one big chunk. And yeah, that should help you guys out. So pre-lab preparation. So this is stuff that in our setup, it's not too bad if you guys do some of this in the lab because it's a small class and we have well, 3 stations right now that are working, but 4 stations in total. So it should be no big deal if you guys do this in the lab, but you could do all of this outside of the lab on your own laptops, which I encourage you to do. So the pre-lab preparation, so complete the following. Make sure your functions compile before running them while connected to the lab hardware. So if you have your own laptop and you have installed the IDE, the Eclipse IDE environment on your own laptop, which I encourage you to do, you should be able to write your own C and compile accordingly. And it's not too bad to get that set up on your laptop. It is a little bit of space on your laptop, but yeah, it's not terrible. And what's nice then is that you can just go into the lab and just plug in your laptop via the USB, and it should just work. The hardware should just work with your laptop if you've set everything up correctly, with no problem. And if you do need, and if your setup's not quite working, you can always switch over to the lab computer, which is, of course, set up to work. All right, so part 1 is user input. So writing the function DoubleIn. Very often in an interaction between a computer and a user, a message or prompt is written on the LCD display, and the user is expected to respond by entering an appropriate decimal number through the keypad. In this lab exercise, you will write a C function called DoubleIn to complete the keypad LCD procedure. This function will be used here and in later exercises to obtain numerical information through interaction with the terminal. It should execute the following steps each time it is called. So a user prompt, a string of ASCII characters, is written on line 1 of the LCD display. A pointer to the string corresponding to this prompt is the only argument of the DoubleIn function. So that's sort of a key idea, is that we're only going to be giving it a pointer to a string. Okay, so the DoubleIn, so if you're going to call it, it would look something like DoubleIn, and then your string. So enter something. Would be how we would call DoubleIn, where I have continued my line on the next line there. So that's the kind of high level there. A floating point number is accepted from the keypad in response to the prompt. If an error occurs in the input string, the display is cleared, an error message is written to line 2 of the display, and the prompt is issued again on the first line. The number is entered as a string of ASCII characters that may include the decimal digits 0 through 9, a decimal point, and a minus sign, and is terminated by enter, the enter button on the keypad. The entered string is interpreted as a floating point number. Okay, so we'll have to interpret it to be that, and of course it has to be a valid floating point number in order for us to do that. The floating point number C, or floating point number, which is a C data type double, we could also do float, but that's only single precision with a double precision. Floating point number, double, is returned from DoubleIn function to the calling program. The prototype of the DoubleIn function is this. So if you have trouble with some of these basic C concepts, I will be reviewing them in the guidance section of this. So that'll probably be the next lecture. I'll split it into the 2 lectures. So the prototype of the DoubleIn function is the following. So you state what type of variable you expect DoubleIn to return, which is a double, and space, and then you've got your DoubleIn declaration. You say that the type of argument that DoubleIn can have, it only have one argument, which is why there's no comma in here. And we have this here, so it's a character array. So there's a pointer, it's a pointer to a character array. So we'll talk a little bit more about pointers and arrays in the guidance section, if that is not familiar to you. For example, to call a DoubleIn, a call to DoubleIn might look like this. So DoubleIn, you might say, okay, enter the velocity, and this is what will be displayed on the LCD screen, like this. Enter velocity, and then when the user types in -50.75, then and then hits enter, then DoubleIn would return -50.75 as a double and assign it to the vel variable. So if any error occurs, for instance, the user enters 2 decimal points. That's, of course, not a valid floating point number, right? You can't have 2 decimal points in there. Then we want our DoubleIn function to say bad key, try again on the second line of the LCD screen. So that makes sense, right? This is not something that we can convert into a double, so we are going to say, try again. We can't accept that input. So we're going to try to catch 4 possible errors. It's mainly not an exhaustive number of errors, but we want to try to catch these 4. So the first type is that no digits are entered. So if enter is hit and no digits were entered before enter was hit. This is the display message, the error message we're going to want to print to the second line of the display. If the up or down arrows are pressed, we want to say bad key, try again. These are not keys that we can accept as part of a floating point number. A negative sign other than the first character. So if the first character is a negative sign, it's a negative number, but if there are any other characters that show up that are negative signs, then that's obviously not a valid floating point number either. Or a double decimal point. Once again, we want to say bad key, try again. So our goal here is that the user must enter a valid number before the DoubleIn function can exit. Notice that the errors are detected in the string that the user enters. Here's a possible strategy for DoubleIn. So this is sort of like the suggested way to go about writing it. Begin by using the Printf LCD function, which we will also write in this exercise, so that's going to be the second part, to display the prompt on the LCD screen. So you can use the Printf LCD that's built in while you write your DoubleIn first. Printf LCD can be written separately because we have the library version of Printf LCD already. So we can use it to write our DoubleIn, and then later on we can write our own version of Printf LCD. So begin by using the Printf LCD function to write the prompt to the screen. And then, step 1, use FgetKeypad, which is a function that gets a string, to obtain the string from the keypad. Its prototype is this. So FgetKeypad, we don't have a lengthy discussion of how it works or the source code for it, because we're going to write our own version of that eventually. But this is the prototype for it, which is to say that it's a function that returns a pointer to a character array, and it has as its two arguments a buffer, which is an array, a character array, a pointer to the head of the character array, and the buffer length, an integer, is the second argument. So when FgetKeypad is called, as in FgetKeypad of string, 40, you're assigning the characters from the keypad to the string variable. So if you call this, then the string variable is going to be assigned whatever the characters are that come from the keypad, which should have been declared to be a character array. So if you're saying that your buffer length is 40, then static character array string 40 would be a declaration of a variable called string that is a character array of size 40, of length 40. However, if enter is pressed, FgetKeypad string 40 returns null. So it doesn't assign it to string, it returns it. So it returns null instead of writing it to the string. So if you if you defined flag equals whatever FgetKeypad returns, and if enter is pressed without anything else being pressed, then flag equals null. So if you assign whatever this FgetKeypad return value is to flag, it should be equal to null if enter is pressed before any digits. So that's a little bit of a help. There were some struggles already on this that I try to help with. And then use the str pointer break, so the string pointer break function to detect the up and down arrows. So note that the up arrow is returned by FgetKeypad as the ASCII character, this left bracket, or bracket, and down arrow as right bracket. So these are what you're going to have to look for in the string, and that this function will allow you to do it. So I would look up the docs on that. So the internet has C function docs. These are all pretty commonly used C functions. Use the same string pointer break function to detect minus signs beyond the first character. Minus sign as the first character is fine. Afterwards, it's not okay. Use string to detect double decimal points. So look up the docs on string as well. And then use scanf, which is another function that you should look up the docs for, which is to scan formatted from string. That's sort of like the name of it, to perform the ASCII string to double conversion. So once you are confident that you have a string that represents a double, then you're ready to go. So hint, because scanf is converting to variable of type double, you need to use the format %lf, which is for long float. So scanf has as one of its arguments a format string, which is %lf for a long float, which is what we need. Okay, another note, Printf LCD and FgetKeypad work like the standard C functions Printf and Fget and are linked to your program from the ME477 library. So, if you're having some confusion about how Printf LCD works or FgetKeypad works, look up Printf and Fget. Try to understand how they operate, and then you're pretty much going to get the same thing with Printf LCD and FgetKeypad, except for instead of working with the terminal, you'll be working with the keypad and the LCD screen. Okay. Write a main program that tests your DoubleIn function by calling it twice from the main program, assigning each result to a different variable. Then, as a check, print the values of both variables on the console using printf. So in your main function is essentially just where you're going to test out your functions that you're writing. So you're going to test out your DoubleIn, you're going to test out your Printf LCD, you're going to test those out from your main program. Okay, part 2. Display on the LCD, writing the function Printf LCD. Our second task is to write the Printf LCD function used by DoubleIn. The C function, printf, prints to the standard output device. In our case, the console pane of the Eclipse IDE. We want Printf LCD to operate exactly as printf, except that we will print the LCD screen. Refer to your C text for more on printf. To do this, we want Printf LCD to accept a format string with a variable number of arguments, which is the trickiest part. So therefore, the prototype of Printf LCD is this. So int, so that means it's going to return an integer type, and then you're going to have 2 listed arguments here. So one's going to be constant character pointer, so array, and then the other one's going to be ellipses. So format is a string specifying how to interpret the data, and the ellipsis represents the variable list of arguments specifying data to print. Okay. The return value is an int equal to the number of characters written if successful, or negative value if an error occurred. Okay, so that's the interpretation that we will take of it, and that's how we have to encode its operation into the function. For example, if n is equal to whatever Printf LCD returns, and you hand it this string, which is a formatting string. We'll talk a little bit more about these special characters and these sort of formatting calls here. and then you have a list of other inputs, a variable number of other arguments. So here's a suggested strategy for Printf LCD. Use the C function VSN Printf to write the data to a C string. So once again, look up the docs on VSN Printf. Okay, that until you understand how that works a little bit, it's going to be hard to use it in your function. Okay, so do that first. Then use the LCD driver function, putChar LCD, which is in the library, to successfully write each character in the string to the LCD display. Note, it is strongly suggested that you use an incremented pointer to access the string rather than an array index. Okay, so we'll talk a little bit more about this in, so this reference is to, so Appendix B is the appendix where all of these lab exercises are described. Lab 01, the one that we're in right now, section 5.1, so this is the guidance section. We'll talk a little bit more about this down there. The C function, VSN Printf, writes formatted data from the variable argument list to a buffer string of a specified size. Okay. The tricky part is passing the variable argument list of Printf LCD to VSN Printf. Here's an example fragment of code. From your C text, study the data type VA list and the C macros VA start and VA end to see how this works. So this is just a way that people pass variable argument lists to C functions. So it's pretty standard. The Kernahan and Ritchie book talks about this. So this is sort of some example code. This is a good place to start, okay, for the Printf LCD function. Obviously, there's more to do, but this is a starting point. So int, once again, it returns an integer. Printf LCD. There's the format array. There's the variable number of arguments. You declare VA list, and args is what we're going to call that. VA start, args and format, you hand to that. N, VSN Printf, you hand it you hand it string. 80, buffer length, format, args, and VA end, args. So this is the general structure of what you want to be using. As usual, you must allocate storage for the C string of length 80. So this is a suggestion to you. This is not, for instance, string is used in here, but it's never declared. So it won't just work if you copy and paste. The main program, the DoubleIn function, and the Printf LCD function should all be in the same file, main.c. That makes it easier for me, but if you choose to write them in separate files, it's okay, as long as you know how to do that. Be sure to use the include keyword, so #include, the header files, me477.h, so this is the me477 library, the standard input-output, standard C library, standard arg library, and string. These are all standard C library libraries except for this guy, which is ours in the code. Once you have defined Printf LCD within your main.c, your code will supersede the version in the me477 library, just continuing to hammer that home. Okay, so the lab procedure is pretty straightforward. Just debug and test your C program. So as necessary, use breakpoints and single stepping to find errors. For this lab, as with every lab, make sure you include all the required parts of the report, and submit your source code, your C code as well. I do want to mention, so you can write these things at home. So if you've got the entire setup working on your laptop, for instance, for the development environment with Eclipse and everything set up, then that's great. You should be able to build the project just fine. So you can debug stuff. You can debug stuff by trying to build before you ever come in and connect it up to the station in here. So it should build. I mean, it might not work correctly, but it shouldn't give you any well, by build I mean compile. It shouldn't give you any compile or build errors if you've written it properly. It doesn't guarantee that it's going to work as expected, but it is a guarantee that at least like you don't have a syntax error, for instance, which when we're starting out with a new language we often have. So it's a good thing to do before you come in. So that's why this this writing of the functions is called a pre-lab, and then the lab procedure is to come in and debug, because you don't actually have to be connected to the system, the development system, the entire development system, in order to do the compiling process. In order to deploy it, to run it, you do need to be. Okay, so that is it for the lab itself. So this was sort of the intro to the lab. These are the procedures, the exercise procedure that we went through. I will come back and do the next section, the guidance section, in the next lecture, because I think it's good to have them separated. So I'll see you guys on the other side.